Okay, so hello everyone. Today, me and my fellow colleague Avi, we will present you a little bit of our work that we are doing in our company, BlackSwan Technologies. And this is about the PEP miner, and the PEP miner is also a part of the smart document understanding. The agenda for today is quite easy. It's about the introduction, some model description that I will be doing. Then we will switch to Avi's demo. By the way, you can feel yourself very chosen because the Avi is from Israel. So all of the demo will be going all the way from the, from Mediterranean Sea, let's say. And then we have a summary and some question answering session. I really hope you will have some questions to me. I even deliberately, I don't will say all of the things that I would like to say, because I hope you will just gather some question. And based on this question, I will be able more to provide you some details, because based on your question, I will be able to know what are you more interested about in our presentation. So the first thing, what is a knowledge graph? Right now, this is a very popular word in our ML community or in the industry. And because I am the mathematician by major, I like to start with the definitions. And here are two definitions that I gathered from a paper, which is towards a definition of knowledge graph. And one of it is knowledge graphs are a large networks of entities, their semantic types, properties, and the relationship between entities. And I would like to highlight especially the entities from this definition, semantic type, or generally speaking, semantic meaning, which is also the part of our job here, and the relationship between those entities. The second definition is knowledge graph could be envisaged as a network of all kind things which are relevant to a specific domain or to an organization. So here I would like to highlight a domain word, because we are operating in the PEP domain, which stands for politically exposed person. Here on the right, you can see some print screen that I took from the Stanford webpage, where they are showing you how this very short sentence can be transformed or translated into a knowledge graph. So you can see the nodes of this graph, like Albert Einstein, Germany, and you can see a relation between those nodes. So you can see that Albert Einstein was born in Germany, right? And this leads me to the very important feature of a knowledge graph, which is fact that it's readable for human and the machines, right? So a lot of tools are already prepared for you that if you ingest knowledge graph, you will be able to, for example, filter the graph or traverse the graph very easily. So as you may guess, this is what I mean when I'm saying that this is readable for machine also. And internally in our company, we like to see 4 features of the knowledge graph in order to achieve our business goals. And the one we would like to have in the graph is, of course, a graph structure. And it comes from the mathematics. In the mathematics, the graph definition is really simple. You just have nodes. Sometimes they are called vertex. You have the edges that are connecting some of those vertices. Sometimes you can even have some number associate with the edges, trying to show you maybe some probability or something like that. Also, a semantic is really important. A semantic is like a meaning. It's like what we could understand from that. So again, I'm referring to this readableness from human and the machines. Also, we would like it to be a smart. And by smart here, we mean also this semantic and this meaning. And generally speaking, that we are able to create some business added value on top of that. So it's not about a theoretical structure that is nice to have in your closet and that's it. We are talking about the structure that could also fulfill other goals, the goals of the business, the goal of the financial domain, or any other domain that you can think of, if you believe that this structure, this data structure, could be useful for you. And the last feature is about being alive. And here I'm just talking about updating constantly this graph, because as you may guess, it's not like we're just taking a snapshot of it and that's it. We would like to always have up-to-date data in the structure. Okay, and right now let's switch to the topic of models, machine learning models. So the first model that of course we need to use here is name entity recognition model. In our knowledge graph structure, the entities will be represented as a nodes, of course. And in this image on the top, you can see our solution example where we specify 3 entity types. One is a person, one is a title, and one is an organization, right? Generally speaking, I can guess that a lot of you are already familiar because this is one of the best well-known models in the NLP, natural language processing domain. And of course, we, as most of the industry, approach this problem in a manner like we have a free text as an input, and this is just a classification problem. We are just trying to get the token's ID, start token and the end token of a different entities for a different entity types. So again, this is just a classification problem on a free text input. As I already mentioned, we are presenting here 3 entity types. And what is very interesting, and maybe for some of you will be something new, in our company, we are able to train our models for a new entity types. So if any one of you already worked with such models in well-known Python libraries like Spacey, you are rather limited to the set of entities type that are already shipped with this model, like location, person, organization. And here in our company, we are able to expand that and to also create a new one. Okay, let's go to the next model. The next model is also well-known relationship extraction model. And of course, the relations are represented in our knowledge graph as the edges between the nodes. And of course, those edges are having a meaning that if a relationship is between those 2 nodes, then we are saying that based on our data, which here are a free text form input data, we are able to spot this relationship. But here, input data are a little bit more complicated than in the case of the NER model, because you don't only provide a free text. By the way, we are naming this a context in such a situation, but you always need to provide subject and object, so the entities. But as you may guess, we already have that. We already have that because those are the entities that we already recognize during the name entity recognition phase, right? So by the way, you can also guess what is the chronology of our models. First, we need to we need to run the NER inference on our text, then gather the entities, and then based on, again, the same text, the same context, and those entities, we are trying to look if the information about this relationship is also in this text, is presented in this text. And very similarly, like with a NER, in a RE, we also have a set of the relationship that we would like to spot. Here in our example on the top of the slide, you can see 2 types of the relations. One is this person is a member, is an employee? So here you can see this arrow on the top. Or second, is this person hold a title, like a politician here? And again, very similarly to a NER, we are also able to define, let's say, new relationship in our solution. Okay, and right now I'm on the 3rd model, which is the last model that we used here. And this model is coreference resolution model. We are internally saying that this is just a helper model. Why is a helper? Because on a free text form, it's very common that you will see a proverbs. So you will see something like he, she, it, her, his, or something like that. And sometimes those mentions, like he, can be connected by some relation to the different information, like he was president at that time, right? So we have a relation between he and a president. But unfortunately, what we would like to have is not this he, because this he means nothing. We don't know exactly what this is talking about. We would rather have a name and a surname of such a person. And here the coreference resolution model comes to play. This model just tries to map those different mentions of the same entity in a free text. So as you can see on our example on the top of the slide, for example, Boris Johnson was mentioned here also twice as a he and as a Johnson. So right now I'm making up from the thin air, but if he would be connected by a per title relation to the state for forging and Commonwealth Affairs organization, so we would have arrow in our RE model, then we would be able to draw the line to the Alexander Boris Johnson. And this is what we would like to have. We would like to have connection between a he and a state for forging and Commonwealth Affairs. We would like to have a connection between this title and our richest representation of this entity, which is usually a name and a surname. In the graph structure, we can still talk about the graph layer. So of course, the coreference resolution is the links between nodes. So you can have a node he, you can have a node state for foraging and Commonwealth Affairs, and you can have a node Boris Johnson. And then you would have what we called in the knowledge graph two hops relation. So you are going from Boris Johnson to he, and then to this title, right? But what we are doing for the sake of readability, we are just merging it. We are just saying, all right, so let us tag this node as the Boris Johnson, and we don't like to have any he or she or her nodes in our graph. So generally speaking, this is just the disambiguation process, right? And here I would like to add that this was just a deterministic algorithm. This wasn't a machine learning algorithm. We know that such an algorithm exists, such a neural models for coreference resolution exist, but we just decide that we will go with the deterministic one. Okay, so, and this is what I would like you to remember from this session, especially what I'm trying to say for the ML community. What are the advantages of the knowledge graph for our ML and industry, ML space or ML environment, you name it? So first of all, for me, what I really like in them is I treat them as an intermediate validation step of our machine learning models. So you will see in a minute that you can very easily spot a mistakes of our models, of our NER model, our E model, or coreference resolution model. Again, why? Because the knowledge graphs are readable for machine and humans. So you will even see by yourself that spotting those mistakes is really easy. What is also really important, and this is what is the main theme of the smart document understanding, is this transition from the unstructured data, which is a free text, to the structured data, which is a knowledge graph. And for me, this is one of the best use cases of the machine learning, generally speaking, not only in NLP, not only in our company, generally speaking. Machine learning is great in this task, from unstructured data to structured data. What is also very important for the knowledge graphs is you can treat them as the starting point for providing graph-based insights. So of course, as always, from the structured data, usually structured data are saved in some database format. And you can run a lot of insights on a tabular storage data, right? But on the knowledge graph, you can do more. You can try to do analysis on this, let's say, classical insights, on this tabular-based data insight, but you can also do more. You can do centrality, community detection, node neighbors, a lot of algorithms already available to you when you have this knowledge graph, when you have this graph data. So you are just very easily expanding with the number of insights, with the number of analysis you can perform on such a stored data. What is also really important is that this is readable for experts. Again, this is readable for humans. So if you have an expert in such a field, like a politically exposed person, or in a financial field, you can always present him or her this graph, and this person would quite easily check if this makes sense and if this is valuable for given problem, right? So this is yet another advantage. And by the way, all of those things that I said already, those 4 points, leads me to the final point, that storing your data in this knowledge graph, or rather transforming your unstructured data to a structured data through machine learning models, can be also perceived as one of the approaches in the explainable AI, because you are having this intermediate validation step. You are able to check yourself, to check if what you really created makes sense, if this really is something that you would like to have and use for other goals, other objectives. Okay, so introducing our solution, I will pass a stage for Avi in a minute, but quick note. This is a web application. We just created in our company a web application. A free text is an input to this model. I try to explain you how we are transforming this free text into this knowledge graph that I said at the beginning. So again, NER, RE, and the coreference resolution models are in place. What is a PEP? Again, PEP is a politically exposed person. So we define it based on the title held. So if someone held the title of a president, prime minister, or the others, then we treat this person as a politically exposed person. But what is more are the relation between them, the relation and connections between to different people, maybe to their family, to their spouses, but also to different organizations, maybe different political parties that they were part of, right? And in our solution, you will see it in a minute, we have two views, I would say. The one is annotated document visualization that contains entities and the relation. And by the way, you already saw the print screen of that before. If you are already familiar with the NLP field, you are quite familiar with this kind of views where you have a highlights for an entity and when you have those arrows between those entities in a text annotated. But what we really like, and this is this final goal of our project, it was the final goal of our project, is this graph network visualization. So exactly this knowledge graph visualization that I talked about. So without no further ado, I will switch to, I would like to switch to Avi's presentation.
Thank you, Kamil. I'm very happy to be here. Thanks for having us. I'd like to further now show a bit more actual in action of what Kamil has been speaking about. So this is our web app, a demo showing how we leverage our NLP models and processes to extract the text. To start and demonstrate, I'd like to show an example network graph story, and I will show you here live how we build it, as well as showing you the root and the source of truth for us, which are the documents and the extracted entities and relations that serve as the source of our building process for the network graph. So as Kamil mentioned, we are targeting politically exposed people. And for the simplicity of our demo, we've defined a specific policy, which is showing a connection of a person entity connected to a title, what we call a title, an attribute title, which we have already defined in the configuration, and I can also change at will. For example, to start, let's say we have a person that we have extracted. In this case, I took a document of Donald Trump from the Wikipedia, no less. And here we can see that because he is connected to a peptidal politician and president, so the machine engine has extracted this information, and we've targeted Donald Trump as a politically exposed person. And of course, as you may or may not know, what's of interest specifically of this person is their influence and their ability to influence society, as well as also possibly to be involved in, they have a lot of power. So it's good to keep check, or to have the ability to keep check. And that's why we'd like to focus in on areas of interest, such as, for example, who are the close people that were related to Donald Trump, as well as organizations. So starting out our story, we would start, for example, with Donald Trump, who is connected to these two titles, which are an alert for us, sorry. For an example, we would show person's spouse, which is definitely closest to that person. And we could see over here on our graph that the system has extracted Melania and Ivana as person-spouse relationship between Donald Trump. I will quickly go over, just to show, as we build this graph out, the root and source, how we can see it actually. This document is, this view is a bit overloaded over here. We have many, showing many connections and entities here. So, but just to show you where how it's extracting and how it's showing us. So for example, we can see over here, Donald Trump as person connected to person titled politician, as well as president, which we've already seen in the knowledge graph. And we can see over here also that Donald Trump has been connected person-spouse relationship, Trump married Czech model Ivana, as well as further down, we can see also that he has also been connected Trump married Slovenian model Melania, which has been brought out and shown over here on our graph. To further focus in on some other maybe interest people of the family, for example, we could see that it's also extracted person siblings, which is very important close connection. He's connected to Robert, Marianne, Elizabeth, and Fred Jr. And back in the document, we could see over here that the source of it, just to see where it's written down, to show how the document is building this slowly, how the graph is being built. So let's see, if, for example, if I want to start searching live for these people, we can see over here, Trump grew up with older siblings, Marianne, Fred Jr., Elizabeth, and Robert, okay? And as we continue building out our graph, for example, we want to see also, for example, organizations and other interesting pieces of information regarding this person. So let's just start going down, just seeing some more relationships that we can extrapolate from this document. For example, person or state of province. So here's a jump actually. Here we can see Maples, which happens to be Donald Trump's second wife, their daughter Tiffany, and California. So in this case, of course, you could see the model is, is a work in progress. Of course, it would have been nice to be able to see Maples directly connected as a spouse to Donald Trump, but the system over here has extracted the fact that Maples, he and Maples have one daughter, Tiffany. So here's another example, for example, of what Kamil mentioned, a co-reference. He meaning Donald Trump, and Maples have one daughter, Tiffany. But because of some of our processes that we are still perfecting regarding our co-reference processing and post-processing, maybe the system could have been a bit more precise in this case, but it still extracted that information. Going further, we can see, for example, person parents. In this case, it connects Maples to Tiffany, and of course, that same relation is the double relation. Person parents is, of course, person child going in both directions. Person country of residence. So here's some interesting pieces of information. Donald Trump is connected to, of course, we know, United States. But it also brings out Scotland over here, which is interesting because Donald Trump isn't actually a resident of Scotland, but if we look back in our documents, where does Scotland show up? So we will even search for it live over here as we're looking at it. So we can see Donald Trump's parents were German immigrants, and Mary Ann McLeod Trump, an immigrant from Scotland. So it connected Trump to country of residence Scotland. And because of our co-reference processing, it connected Donald Trump obviously over here to Mary Ann and therefore to Scotland. So there is obviously work that we're still perfecting. The system is bringing out some pieces of information, but of course we can see places, and it's very interesting, as Kamil mentioned also, that it's a very nice and easy way for us to be able to visualize, backtrack, see where the document went wrong, and then go back into the post-processing and modeling techniques to try to perfect our system. City of birth, New York City. I won't go back for every single piece, maybe, just to not bore everybody over, because we can see what the system's doing. City of residence, also New York City. And here's another interesting point, as we can see. Donald Trump and Trump obviously are the same person in this case. This is an example where the system extracted Donald Trump and Donald John Trump and Trump. It has done, by the way, it has done some pre-processing. Some of these nodes, by the way, are not just directly connected to Donald Trump. We have co-reference, and that's why we have so many connected just to Donald Trump. But of course, it's not perfect. So we still see an example here where Trump has not been merged to the original Donald Trump entity extracted. Going further, we could see date of birth, which is pretty, specific piece of information. Donald Trump born on June 14th, 1946, as well as his daughter Tiffany in 1993. We can even see that specific information over here in our document. Donald Trump was born, and here it's person date of birth, June 14th, 1946. At the same time also, if we go further, we could see that, sorry, hold on a sec. We could see that organization, city of headquarters for example, we see over here school, there's a school. So all the schools that Donald Trump has attended, schools attended, we have quite a few. Also, its roots are in the document, which we can show. And also we have titles of other titles. We've separated between different titles, both PEP and otherwise, PEP titles as well as other titles. For example, we could see here that Donald Trump's both wives were models. So we know Donald Trump likes marrying a model, which is understandable. And going further, I see we have, so this is basically an overall search and picture of the overall analyzed documents that we've had, in this case, specifically the one document. And we have multiple documents that we can show that I've preloaded beforehand also, and we can also try on the fly. But I think for time-wise, we'd like to leave some more time, go back to Kamil and leave more time for Q&A. So at this point, I'd like to pass it back to Kamil. Thank you. Can we?
Okay, so to be honest, the last I have just last slide, but of course we can talk a little bit more about it. What I would like you to get from this session. So first of all is that the knowledge graph are the practical data structure. I need to admit that we didn't show you much how this is a very practical, because in order to show you that, you would need to run a lot of insights on it. And Avi very nicely showed you verbally how those insights could look like preference of Donald Trump towards the models. But what I would like you to know, and of course you can try to also check that and check if I'm saying a truth, is a lot of algorithms are already in place, and a lot of Python libraries are already in place in order to traverse the graphs and in order to gather some analysis based on the graph structure. So this first point, you just need to trust us that this is really something useful. This is really something worth investing our time and investing our energy in order to create those graphs correctly. And as I said, you already also saw a couple of mistakes of our solutions. And as Avi said, we are also trying to have it better. But I believe you understood this general goal that we have in our mind. Be able, from a very long text, like from the paragraph, from the Wikipedia or something like that, to automatically have this knowledge graph structure about this person. Second of all, you saw how those ML models are very useful tools in order to transform a data to information. I have this image of the pyramid from data to information, from information to forecast, and from forecast to action. Of course, this is very nice visualization, maybe also useful for the business people to show them that having a data is not yet what you would like to have in order to gain some money, to have some goal in front of your eyes. In order to achieve something useful, you need to go, you know, higher and higher in this ladder, in this pyramid. And here we just showed you how you can, with the help of the machine learning models, to take this one step ahead, to get from the data, which is the free-form text, into the information. And by the way, this is exactly the same what I said, from the unstructured data to the structured data. And this is really, really powerful. Again, what I said, the knowledge graphs are useful for gathering insights. So even again, Avi verbally showed you how much he can get from this graph view that he showed you. So yeah, I believe this goes without saying. And the last thing that I would like you to highlight, which is usually the situation, is what are our next steps in order to show you that, of course, this is just the beginning of our journey in that direction. So our goal for this year is to have a tool that will not only show you the graph view, the knowledge graph of a one person from the one paragraph, but to show you the whole net of people from different paragraphs, from different data sources. And in order to achieve that, we think we need to have at first classification model. And by the way, this classification model is only for the purpose of efficient calculation. We just don't want to run our complicated models like NER and RE on the paragraphs that are not related to, for example, politics, right? So to put it easily, when we would have a classification model that will classify a news to the sport, politics, and environmental news, then we would just choose those one from the politics group in order to, run those big guns as a NER or RE only on those paragraphs. But what is a more complicated and much more complex in terms of the machine learning models is the entity linking. So being able, this is like a second level of the coreference model. It's like finding a connection, finding the mentions of the same entity across different paragraphs. Is really not such an easy task. Is really the coreference resolution model is much, much easier, especially, as I said, it can be based on the deterministic rules, not even in the machine learning like a neural network model, but entity linking is much, much more complex. But of course, this is really needed if we would like to have this full view of the political global situation, so to have all of those crazy connection and paths between the very well-known politicians like Donald Trump and Angela Merkel. So for example, how would you create the path between those two, right? But also, what I would like you to know from this session about the solutions that we are creating, and I believe this is usually the case in whole machine learning industry, that of course you can always experiment with different models. You can always, and by different models, I also have in mind changing the hyperparameters, changing training data. You know, a lot of work can be done here. But, and this is why I want to have it as a separate point, is that you can also experiment with the different policies. So please remember that sometimes changing a model is a really big deal. It's really costly, can really be costly. And sometimes you can achieve your goals by setting in place simple policy. And for example, we have a number of policies in this solution. To name one, the policy to disambiguate between entities from NER and entities from the coreference resolution model, right? So also think about that. Maybe it's easier and cheaper to just have some deterministic policy in place or any other policy in place in order to achieve your goal. You don't need to start from the machine learning models, which are very complicated and also very hard to set, very hard to steer. So please remember that those kind of the things like policies can also be useful for you. So don't forget about them. And I believe that's all that we would like to show you, and we are really open to any questions.